Welcome. So in this video we're going to use mainly the GeoGebra app that I have here to explore the calculation of distance between 2 points. Now it's very easy to calculate the distance along the number line, the x number line, when one of the points is 0, 0. So the distance here would be 4. But if we translated that up to any horizontal leg alone of 4, it's quite easy. You subtract the two unlike values. The 2 and the 2 basically mean there's no difference in the vertical and there's only a difference in the horizontal. Okay. Similarly, if we have a horizontal line segment, there's no difference in the vertical. You see the ones are the same, and you look at the difference of 7 and 2, which is 5. 7 subtracted 2 is 5. And it's the absolute difference, because one of the things our theorems tell us is that distance must be positive between 2 points. Okay, so even if this was down here, 5 down instead of 5 up, it would still be a distance of 5. And notice then that you're getting 2 and -3. And how do we get 5 from that? Well, what we could do is we could say that if the signs are different, we ignore that fact once we've recognized it and identified it, and just add the magnitude of the numbers. So add the 2 and the 3 if the signs are different. Yeah, that's all fine and well, but what if both signs are negative, like here? Okay, we'll ignore the -4. Actually, we'll put them up here just to make sure there's no confusion about that. Okay, so we'll ignore the fact that they're both 3, at least that means that we have a horizontal line segment. But now -7 and -2 are both that have the same sign. So it's the exact same situation as if they're both +7 and 2. So you just ignore the sign when they're both the same, and you subtract 7, take away 2 is 5. Okay, now that'll be important as we move on into the actual use of the formula. Now let's take a quick look at page 18, which I have here. Okay, you see down here that this is page 18, and all of these equations here are based on this line segment from P, which is x1, y1, and the one on the right hand side, Q, x2, y2. Now I emphasize that it's the right hand side because you're using the one to the right to start your difference. x2 take away x1. It's not essential, but it saves a lot of trouble in terms of ending up with a negative over a negative, which you just would rather avoid by a little bit of pre-planning. So where's our distance formula? Here it is here. Now before we look at it, we should look at what it says here. The length of, what do these square brackets mean? So what they mean is the line segment, including the end points. Okay, it basically means that from P to Q, line segment, and it's only a line segment, and then we're talking about the length of it. Well, then what's the mathematical notation for length? And it is these two pipes or bars to the side of PQ. So the pipes are translated by you into the distance from P to Q is equal to the Q coordinate of x minus the P coordinate of x, all to be squared, plus the y coordinate of Q minus the y coordinate of P, all to be squared, which is just those different line segments that we spoke about earlier. And when we do some practice, we're going to show how to use a bit of intuition to calculate. Okay, we'll jump back to my applet now, and so let's just stay in the positive quadrant. Okay. So looking at the difference in the x's, we have 5. Specifically 6 take away 1, we have here, all to be squared, plus, this plus will never go away. Everything in red here, you can kind of start off with. It's part of the skeleton, including the square root, it's part of the skeleton of the equation. And then whatever goes inside in the blue will be the difference in the x's, and the purple will be the difference in the y's. Okay, so you have 6 take away 1 and 7 take away 4. Okay, so we can simplify that to 5 squared plus 3 squared. No need for the brackets there. And the reason they're putting the brackets there is sometimes they may be negative depending on how the software does it, and that's fine, and it'll happen for us too. But what we can do is just ignore negatives here and kind of shortcut over that. Okay, then we can expand the squares. Okay, simplify the radicand to 34, and that does not simplify, so that's the exact value. You can try that on your calculator. You should do these on your calculators from here onwards, because just to look out for the fact that the surd might simplify, but it doesn't, and that's the approximation for it. Okay. Now there's a hints option here if you get stuck, which will show you the other sides, the horizontal side and the vertical side of the supplementary triangle that helps you do the calculation. Okay, let's make up a random question. Now the purple values, the y values, are both positive, so I'd be thinking the second number here would be 6 squared, but the horizontal values, the x values, are of different signs, so we'll add 3 to 2. So I'm expecting 5 squared plus 6 squared to occur. Okay, now they have minus 6 squared, that's okay. That's the correct way of doing it, from its corresponding coordinates to corresponding coordinates. Okay, go ahead and add them. 61 is a prime number, so absolutely, definitely that won't reduce. Okay. So now I'm going to set one to demonstrate something to you that's quite important. So if I make the difference here 8 and 4, what's common between them is 4. So this distance is 4 times bigger than if the distance were 1 and 2. Now 2 squared and 1 squared is 5, so this will be 4 root 5 by the time I'm finished. Now they haven't simplified the surd, which is a little bit dangerous because you can lose points here if you don't write 4 root 5. If you put root 80 into your calculator, you'll get 4 root 5. I won't do that, it's quite a simple thing to put in your calculator. Okay, so keep making up random values, calculate it yourself. If you just bring the coordinates back onto screen if they go off screen, and roll. You can always pinch the screen or roll your mouse if you're using a computer to change the scale so that you can see everything you need to see. Okay, enjoy this app. You can use it to practice your distance calculations and to improve your understanding. Just quick one, 14 squared plus 2 squared, 2 would be common. 7 squared and 2 squared, root 53. So 2 root 53 would be the answer there. They're not going to simplify it in surd form. Square root 240. Thank you.